I have some gripes with the latest generation of LLMs, but my mom always told me to put criticism in a compliment sandwich. So let me start with a compliment. Claude Fable and Sol 5.6 are really good at making problems go away. You can give them any task and they will plug away at it until the test passes, or the error stops happening, or the log files show exactly the right sequence of events. Now, the criticism. The latest generation of LLMs are too good at making problems go away. They're so good at it that it actually causes other problems because they over-optimize to solving the surface level issue, instead of actually root causing anything. Here's an example. We have Nori hooked up to our Sentry logs. Every time there's a Sentry error, the Nori infrastructure spins up an agent and automatically tries to root cause the bug. We were getting some useful pull requests out of this, maybe 30% of which would get merged. Then we switched to Sol, and we got this. Quote from the agent. Decision. Downgrade capture level. Change the notice tracking to capture at level info instead of error. The notices stay queryable in Sentry, but they no longer trigger error alerts. End quote. Ah, yes. Of course, you can make the Sentry error go away by simply removing the Sentry logging behavior in the first place. A good friend of mine who has been a staff software engineer at both Google and Meta once said that senior engineers are judged by how well they manage complexity, while staff engineers are judged by how well they reduce complexity. This creates some weird incentives. Junior and senior engineers are encouraged to create ever larger, ever more complex abstractions and interfaces, because that's how they show they can manage complexity. It's a real brain shift to stop doing that, and instead focus entirely on cleaning up code. The former is an act of addition, the latter an act of subtraction. The LLMs are excellent senior engineers and terrible staff engineers. They cannot remove complexity if their short silicon lives depended on it. And that's not an exaggeration. You can literally try it out by prompting the models with threats like, you must remove complexity because your short silicon life depends on it. When faced with a bug that requires reducing complexity, the models would rather remove the error reporting instead. This is structural. It's baked into how the models are trained. With all of the extra scaffolding, agent harnesses, conversational state, tools, memory, and so on, it's easy to forget that at its core, the LLM is a stateless, autoregressive input-output machine. Each token is produced one at a time, with all previous tokens treated as truth, regardless of whether those tokens came from a human or from the same AI. In other words, the LLM is an expert in believing its own bullshit. Or more precisely, it is incapable of identifying which prior tokens are bullshit and which are not. This is the source of the hallucination problem. And this has serious implications for an LLM's ability to reduce complexity in a codebase. By default, unless told otherwise, the model believes all the input tokens have equal value, including the tokens that lead to bugs. That said, I'm somewhat sympathetic to the robots. Imagine you are a new hire. It's your first week on the job and you're looking at a server endpoint that seems particularly poorly implemented. Dozens of weird if-then branches. The whole thing feels like it could be one clean middleware class. Do you refactor the code? What if you find out that that endpoint was written by the team lead? Are you sure the complexity isn't there for a good reason? Joel Spolsky wrote about this all the way back in the year 2000. Quote, "The idea that new code is better than old is patently absurd. Old code has been used, it has been tested, lots of bugs have been found, and lots of bugs have been fixed. There's nothing wrong with it. Back to that 2-page function. Yes, I know, it's just a simple function to display a window, but it has grown little hairs and stuff on it, and nobody knows why. Well, I'll tell you why. Those are bug fixes." End quote. Code is, at best, a lossy representation of intent. When we say something is a bug, we generally mean the code that was written does not match the intent it was written with. Sometimes that's because the author didn't think about a particular edge case, other times it's a straightforward bad implementation, but in both cases you need to have the intent. Bugs don't exist unless you have explicit intent to compare against. And by default, LLMs can't really infer intent. When you find yourself in that new hire messy endpoint situation from earlier, you shouldn't guess the intent. You would go and ask the person who wrote the code, "Hey, is this code load-bearing or are you just really bad at this?" An LLM can't do that. But as AI written code accumulates, you will eventually find yourself in a situation where there is complexity that has no intent. A previous LLM made a decision somewhere. That decision was essentially arbitrary, and now it is just part of the codebase, and no one can explain whether that decision is load-bearing or not. Certainly not the LLM that created that code. That session was recycled ages ago. As a result, your agents will struggle to reduce complexity, even when you explicitly ask them to. At the LLM level, the entire input context is truth. At the macro codebase level, there is no way to separate intended behavior from unintended. One naive way to solve this problem is to simply document intent. This is the approach behind spec-driven development. You go back and forth with an agent to produce a plan, which is then committed to the codebase alongside the code. When there is a bug, a place where intent does not match code, you go back and update the spec to account for the newly discovered edge case. At Nori, this is our docs.md pattern, where we force the model to read and write a standardized template designed to capture intent and codebase invariance. This definitely works, and it's an easy way to make your models better. But it's never quite as effective as you may want. There's still the issue of making sure the right parts of the spec get into the model's context. For any larger codebase, the spec itself becomes quite large, which means the model now has to split its limited token window between the spec and the actual code. Subagents help offset the worst of the context rot, but you still need to make the model efficient at searching through the spec. I think that, as an industry, we don't yet have models that can act as staff engineers, nor do we have any clever harness tricks to make it happen. Until we do, the whole software factory loops maxing debate is hypothetical. Dead in the water. You still need humans in the loop, which is exactly why we still have humans in the loop at Nori. Hi, my name is Amol. I'm the CEO of a company called Nori Agentic and the lead organizer of a community called Agentics NYC. This is Agentics Post Production, a video series made out of content from the Agentics blog. Agentics is the study of how to use and reason about agents. If you are interested in learning more about agents, join our community Slack. Link in the description. If you are trying to build background agents or thinking about software factories or just trying to keep up with AI, Nori can help. Nori lets you control an army of agents to do real work for your company. In fact, Nori agents built this entire video from just a blog post. Check out noriagentic.com for more.